Hey guys, welcome back to Angeli's Math Desk. In today's video, we will be continuing with the topic squares and square roots. In today's video, we will be talking about finding the square of a number. So we know it's easy to find squares of small numbers like 2, 3, 4, 5, 6, etc. But it's not so easy when you have to find the square of something like 23, right? So, because it's 23 times 23. Now, what can we do with 23? We can write 23 as 20 plus 3, right? Therefore, 23 squared can be written as 20 plus 3 whole squared, which is 20 plus 3 times 20 plus 3 essentially. Now, when we were to open these brackets up, we will get 20 times 20 plus 3 plus 3 times 20 plus 3, right? And then that's 400 plus 60 plus 60 plus 9, so which is 400 plus 129, which is 529. Therefore, 23 squared is 529. Now, let's do a few more together. Try to find the square of 42. How can you break 42 down? You can break 42 as 40 plus 2, correct? So therefore, 42 squared will be 40 plus 2 whole squared, which is 40 plus 2 times 40 plus 2, which is 40 times 40 plus 2 plus 2 times 40 plus 2, which is 1600 plus 80 plus 80 plus 4, which is 1600 plus 164, right? Which turns out to be 1764. Therefore, 42 squared is 1764. Now let's look at some other patterns in squares. Let's say we have a number with unit digit as 5, right? Therefore, a5 whole squared, how can you write that? That would be 10a plus 5 whole squared, okay? Now, here a can be 1, 2, 3, 4, 21, 22, 23, whatever number, but we're talking about cases where the unit digit is 5. So now let's solve this and see what will be the pattern for the squares of numbers with unit digit as 5. So a5 squared equals 10a plus 5 whole squared, right? Therefore, this can be written as 10a plus 5 times 10a plus 5, which is 10a plus 5 plus 5 times 10a plus 5, which will be 100a squared plus 50a plus 50a plus 25, which turns to be 100a squared plus 100a plus 25, or you can write that as 100a plus 1 plus 25, right? Let's write this there. So now let's look at 25, right? What would be 25 squared? It is actually 625. So let's talk about why 25 squared is 625, or why did I write it as 2 times 3 hundreds plus 25? I wrote it 2 times 3 because our a here is 2, and using this formula, it's hundreds, a times a plus 1. So a is 2 and a plus 1 is 3. So 2 times 3 hundreds plus 25, which will be 6 100 plus 25, which is 625, right? So now let's look at 35 squared. What would be 35 squared? We'll write that down later. But in this case, our a is 3. So it will be 3 times a plus 1 is 4 hundreds plus 25, which will be 12 plus 12 hundreds plus 25, right? So 1200 plus 25 is 1225. Now let's look at 45 squared. What will that be? It will be 4 times 5, because a is 4 and a plus 1 is 5, hundreds plus 25. So what is 4 times 5? It's 20. So 20 times 100, which is 2000, plus 25. It'll be 2025, right? There we go. So easy to find the squares of numbers with 5 as their units placed. Now let's talk about Pythagorean triplets. Okay, so consider the following. 3 squared plus 4 squared. What is it? Squared. 3 squared plus 4 squared. What is it? 9 plus 16, which is what? 25, which is what? Actually 5 squared, right? Therefore, we can say that 3 squared plus 4 squared equals 5 squared, right? In this case, 3, 4, and 5 are Pythagorean triplets. Okay? Similarly, 6 squared plus 8 squared is what? It's 36 plus 64, which is 100, which is actually 10 squared, right? Similarly, 6, 8, and 10 are also Pythagorean triplets. Now let's try to generalize it. Let's try to generalize it for any natural number m, right? So for any natural number m greater than 1, we have 2m squared plus m minus 1 plus m squared minus 1 whole squared equals m squared plus 1 whole squared. So 2m, m squared minus 1, and m squared plus 1 are Pythagorean triplets. So when we generalize it, this is the formula. For any natural number m greater than 1, we have 2m whole squared plus m squared minus 1 whole squared equals m squared plus 1 whole squared, where 2m, m squared minus 1, and m squared plus 1 are Pythagorean triplets. Okay, now let's try to solve a question for Pythagorean triplets. The example we have at hand says, write Pythagorean triplet whose smallest number is 8. So we know that the triplets are 2m, 2m minus 1, and 2. We know that the triplets are 2m, m squared minus 1, and m squared plus 1. Let's say that the smallest is m squared minus 1. What does m come out to be? 3, right? But then our 2m comes out to be 6, and m squared plus 1 comes out to be 10. Whereas where the smallest number is 8. So definitely this is not going to work, right? Because we're finding a number smaller than 8, which is 6, right? So now let's try 2m equals 8, right? What does it mean? It means m equals 4, right? Therefore, what is m squared minus 1 now? 16 minus 1, which is 15, and what is m squared plus 1, which is 16 plus 1, which is 17. Now, Therefore, our Pythagorean triplet with the smallest number as 8 is actually 8, 15, and 17, right? Okay. Now let's solve some questions together. The first one is find squares of the following numbers. Let's say we start with 86. So now we're just going to solve questions with the concepts we learned today. So find squares of the following numbers. Looking at 86, we can break 86 as 80 plus 6. Therefore, 86 squared will be 80 plus 6 whole squared, which is 80 plus 6 times 80 plus 6, which is 80 times 80 plus 6 times 80 plus 6, which is what? 6,400 plus 480 plus 480 plus 36, which is what? 6,400 plus 960 plus 36, which is 7,396. Therefore, 86 squared is 7,396. Let's do the square of 71. How can you write 71? 71 can be written as 70 plus 1. Therefore, 71 squared will be 70 plus 1 whole squared, which is 70 plus 1 times 70 plus 1, which is what? 70 times 70 plus 1 times 70 plus 1, right? Which is what? 4,900 plus 70 plus 70 plus 1, which equals to be 4,900 plus 140 plus 1, which is 4,900 plus 141, which is 5041. Therefore, 71 squared is 5041. Okay, now let's move on to the second type of questions, which is finding Pythagorean triplets. Here we're asked to write the Pythagorean triplets for numbers with at least one number that is, let's say, 6 in the first part, right? Now, we know that the Pythagorean triplets are 2m, m squared minus 1, and m squared plus 1, right? We can pick any number, 2m, m squared minus 1, or m squared plus 1 to find what m is, and then find the Pythagorean triplet, because we haven't been told that the smallest number has to be this or the largest number has to be this, right? So let's say we just pick 2m equals 6, which implies m equals 3, right? Therefore, what will be m squared minus 1? M squared minus 1 would be 9 minus 1, which is 8, and m squared plus 1 will be 9 plus 1, which is 10. Therefore, the Pythagorean triplets in this case will be 6, 8, and 10, right? And now part B is to find the Pythagorean triplets whose one number is at least 16, right? Again, we know it's 2m, m squared minus 1, and m squared plus 1. So let's say 2m equals 16, which means m equals 8. Therefore, m squared minus 1 is 8 squared, which is 64, minus 1, which is 63, and m squared plus 1 is 64 plus 1, which is 65, right? Therefore, our Pythagorean triplets are 16, 63, and 65.
So this brings us to the end of our video. If you guys do like my videos, please do not forget to like and share this video. Also, please do leave a comment down below. Please do subscribe to my channel and hit the bell icon so you never miss a video ever again. If you guys have any other questions with regards to other math topics, please do not forget to leave them in the comments down below, and I will get back to you on those as well. Bye for now.